This is a review of Problem 1 in Exam 3. Problem 1 has multiple choice and conceptual questions, and you show work for partial credit. Part A, upon what basic quantity does kinetic energy depend? Well, kinetic energy is defined as 1/2 mv squared. So it depends on mass and it depends on speed. So the choice is I. Part B, a .500 kilogram ball moves in a vertical circle at the end of a 1.50 meter long string. When the ball is at the bottom of the circle, which is the correct expression for the tension in the string? So if we draw a figure of what's happening here, we have the ball at the bottom. It's rotating in this vertical circle at a radius r from the center. Then the forces acting on the ball, if we do a free body diagram, are the weight acting down and the tension acting up. And the net force is in the direction of t, causing an acceleration equal to v squared over r, the centripetal acceleration. So Newton's second law says that T minus mg, that's the sum of the forces in the y direction, is equal to m times a, where a is v squared over r. So T is equal to mg plus mv squared over r. The correct answer is choice 2. In part C, bullet B is fired with the same speed as bullet A. Bullet A has half the mass as bullet B. If bullet A has kinetic energy K sub A, what is the kinetic energy of bullet B, K sub B? When we know that the kinetic energy is equal to 1/2 mv squared. If the velocity stays the same and the mass doubles, then the kinetic energy must double. So the kinetic energy of B must be equal to 2 times the kinetic energy of A. In part D, an object can be slid down one of the 3 different ramps as shown to the right. The object starts from rest, and the final elevation loss of each of the ramps is the same. If there is no friction, rank from largest to smallest the speed of the object at the bottom of each ramp. It doesn't ask which ball gets to the bottom first. It wants to know what the relative speed is of each of them at the bottom. Well, in each case, the change in the potential energy is the same because the same change, each experiences the same change in vertical position, h. And since there's no friction, then mechanical energy is conserved. That is, change in K plus change in U is equal to 0. So the change in kinetic energy in each case is equal to minus the change in the potential energy. And the change in the potential energy is the same for each, since each undergoes the same vertical displacement h. So each has the same speed at the bottom, and so they're equally ranked. You could write it v sub x is equal to v sub y is equal to v sub z. And that concludes this review of problem 1 from exam 3.